All right, here we go. We are going to talk about this, areas. So this whole chapter has been about areas, except for the last two lessons. The last two lessons have not done anything with area, okay? But it has taught you something that's going to help you do what we're going to do today, at least one of the things that we've done before, okay? So we know how to find the areas of a bunch of things, right? Area of a rectangle, area of a triangle, parallelogram, trapezoid, rhombus, all those things, okay? What we're going to concern ourselves with is the area of a regular polygon. What does it mean if a polygon is regular? All the sides are equal and all the angles are equal, okay? I'm going to make this. This is not really an example, this one right here. This is just so that we can talk about a few words and what they mean. We got to do that first before we actually do some work. Actually, let me do this. See that little dot right there, right in the middle? That's what I like about using this program, is that tells me exactly where that is, so I don't really have to guess. So let's talk about that right there. We've talked about this in terms of a circle before, but we haven't talked about this in terms of a polygon. And again, this is not just any old polygon. The stuff that we're going to do today only works with what kind of polygons? Regular polygons, okay? So it doesn't work with anything. Only when it's a regular polygon. Only when all the sides are equal and when all the angles are equal. Everybody got it? So I got a five-sided figure here, a pentagon. So it's a regular pentagon. But the fact that it's a pentagon really means nothing right this minute, okay? Later on it will, not right now. But I want to just name some stuff, okay? Let's just label some things. So that little point right there is called the center of the polygon, the regular polygon. Just like we had a center of a circle, didn't we? Remember we had the center of the circle? We also had something else that dealt with a circle. Like if I drew a line segment from the center to a vertex. Now we didn't have a vertex of a circle. We just had any point on the circle. So this doesn't go to just any point on the circle. This specifically goes to where? What did I just say? A vertex. And a vertex is where those sides meet. Is that the only vertex on this thing? No, there's a bunch of them, okay? Well, not a bunch. There's exactly how many of them? 5 of them, okay? There's 1, 2, 3, 4, 5. So there's 5 vertices, okay? On a circle, what was it called when we went from the center of the circle to anywhere on the circle? That was called it's a segment, but it's more specific. When it goes from the center, what's that? It's not a mid-segment. It's the radius of the circle. It's the radius of the circle. So guess what this is going to be called? This is the radius, all right? It's a little different than the radius of a circle because it can't go to anywhere. So for instance, if I drew like from here to here, is that right there the radius of the circle? No, because where does it have to go? It's got to go to a what? Vertex. Okay, it's got to go to a vertex. I'll just draw them all in here just so you can kind of see them. So what do we know about all the radii? What's that word, radii? Where'd that come from? So plural, right. If you have more than one radius, it's radii. You got 2 radii, 3, 4, 5 radii, okay? So how many radii do I have here on this pentagon? I've got 5 of them. And tell me something that's true about all 5 of these radii. They're all equal to each other, exactly right. So that, this one, and this one, every one of those radii are exactly the same. Make sense? Okay? Now, when I draw these things, now this is the center of the circle. It's a point, okay? But what about this angle right there? That has a special name. It's the angle that's formed by the radius, by 2 radii intersecting at the center. All right, that's a lot of words, but see where they intersect each other right at the center right here? Okay, at the center. All right, that's a key, right? We're not talking about this angle down here. Does this angle right here intersect at the center? No. These 2 radii intersect at the center. It forms this angle, and we call this the central angle. Central angle. Nate, could you go out there and tell Josiah he needs to be in here? All right, so this right here is called the central angle. It's important that you know this. Everybody understand? Is he there? Tell him I said he needs to come in here. Don't just wave to him. So this is a central angle. Let's see what else I want to say. Okay, I got one more thing. You going to bring the desk in? Josiah, go bring the desk in. You're doing it to yourself. All right, let's keep trying this. Okay, one more thing. Here's a word. Now look, you probably understand what a central angle is, and I don't know if we really talked about it before, but you've heard of center, you've heard of angles, you've heard of all that kind of stuff. So this one is one that you probably have not heard of before. All right? And watch what I'm going to draw. I'm going to draw it to here, and I'm going to make it perpendicular. Now, we've done this stuff before. We have drawn something from a point perpendicular to another side. We've done that before. All right, so that's not brand new, but this word is brand new. All right, this word is a word that you have not heard before, and it's not that big of a deal, but it's called the apothem. Apothem, that's an M. A-P-O-T-H-E-M, apothem. And that side right there is pretty important for when we find the area of a regular polygon. We haven't even begun to find the area of this polygon yet. Okay, we got to work our way up to it. All I've done right now is just describe some words to you, describe what this angle is, describe what this side is, describe what this side is, the apothem. All right. If you notice, and this is what we're going to be looking for when we actually find the area, okay, on some of them anyway. You've got, what do you have right here? What is this? Yeah, it's a right triangle. If I could draw that a little bit better. There we go. Yeah, you got a right triangle right there, don't you? Everybody okay with that? Yeah. So we're going to use that. This is one of the sides. What is the radius? On the right triangle. The radius could also be considered the what? The hypotenuse, because it's opposite the right angle. Are we seeing all that now? All right, it's very important. All right, that you see that stuff. There's one more thing that we need to cover before we actually start talking about the area. I haven't even mentioned area, have I? Well, I mentioned it, but I haven't even mentioned how to get it yet. All right, we've just talked about these words. So there's another thing that's really important to see, and I am going to use a different polygon. This is example 1. I don't think I wrote that in the last class, but that's okay. And I'm going to draw another regular polygon. And this time it's going to be an octagon. How many sides does an octagon have? 8. So there's 8 sides right there. And what's true about all the sides, all the angles? If it's a regular octagon, they're all equal to each other. Okay? Actually, let's keep that there. And I'm going to put a center right there. Now, check this out. I'm going to draw all the radii. Okay, so I'm going to go from each vertex. So how many radii will I have on an octagon? I got 8 sides, so how many of these am I going to have, do you think? I'm going to have 8 of them, that's right. There they are, all 8 of them, beautiful. What I'm going to do, what we're going to do together. Oops, didn't want that. Got to click off of that. There we go. Now I can make it red. All right. What we're going to do, we are going to find what that angle is right there without me giving you any other information. Okay? That's it. I'm not telling you any numbers. I'm not telling you any angles. All I'm asking for is you to find that red angle right there, and you will be able to find that red angle. And you're going to have to find that red angle on several occasions. All right? So how in the world do we do that? Well, I'm glad you asked, because this is how we're going to do it. If this angle is a central angle, then what's true about all the central angles? They're all equal to each other, exactly right. So I'm going to draw them all in here because I want What's it kind of looking like? Kind of. Yeah, it's kind of looking like a circle, isn't it? Okay? So if I start at one point and I go all the way around a circle and end up to where I started from, okay, how many degrees is that? It's 360 degrees, right? My son was into scooter riding for a real long time. He actually moved to San Diego, California for 5 years because of scootering. He lived in a house with a bunch of his friends, and several of his friends were like, quote, professional scooter riders. It's not like they made tons of money. They barely made a living, but that's what they did for a living. They rode scooters. They would go to competitions. They would be on videos. And my son was one of the guys that shot video of those guys. And he was a pretty good scooter rider. He wasn't on the professional level, but he was a pretty good scooter rider. But he'd go out and he would do that. And one of the tricks with skateboarding and scootering and all that, even in basketball, right? Some people can do a what? You go up and you do a dunk and you go all the way around one time. What is that? A 360, right? You've heard that before, right? I don't know if you watched any like skateboarding and stuff, but or snowboarding. I watched something with my son the other day. Well, it was several weeks ago, probably a couple months ago, maybe. This guy did, I forget what the number was. It was the craziest amount of rotations. It was the most rotations anybody has ever done. It was way more than that. It was like over 1,000. It was like, I don't know exactly again, but it was like 7.5 rotations or something crazy, going around in the air. But when they do those angles, they say that was, again, I have no idea what the numbers are. I don't know. Let's put it in there. Let's see. Let's say it's 7 times. I don't know. It might be more than that. I just can't remember. So 7 times a 25-20. Let's say, oh, he did a 25-20. And at some point, I think it's probably better that you quit using the degrees, right? A 25-20, I have no idea how many that is. So what do? If somebody said, that guy did a 25-20 divided by, not 7, because you don't know how many times he went around, divided by what? 360, right? Would you agree? Okay. So let's take a look at this. Now, we're not going around a whole bunch of times. We're only going around once. And we're only going around a fraction of 360. So what would this angle, any of these angles, what would just one of those angles be? How would we figure it out? We go 360, what? Divided by, how many angles do I have? This is an octagon, so I divide it by 8. That's right. So this angle right there, that's all you had to do. I didn't give you any other numbers, did I? I just told you how many sides this has, and that it's a regular octagon. So how do I find one of those angles? I go 360 divided by 8. And I've done that already, and that is 45 degrees. So that's kind of interesting, isn't it? That you could figure out that angle without knowing anything else. That's all you know, is it's an 8-sided regular polygon. That's all you knew. But you could find that. What if it was a 10-sided, a decagon, and it was a regular polygon? What would each central angle be? It'd be 360 what? Divided by 10. Right? And that would be 36 degrees. Everybody see that? So the more sides you have, what's happening to that central angle? It's getting what? It's getting smaller. The less sides you have, let's go 360 divided by 6, hexagon. What would that be? How about 60? Okay. 36 divided by 6 is 6 plus the 0, 60. Does that make sense? So here's what the book says. What if you had n number of sides? Meaning n could stand for any number, right? N number of sides. How would you find the central angle? You go 360 divided by what? By n. That's it. And that's your central angle. You with me on that? It's pretty easy to figure out, isn't it? So you can actually figure out what that angle is right there. And a lot of times that angle is really, really important to figure out. Okay? So that was good. Let's go a step further. This is another thing that can be very important for you to figure out. Oops, I thought I clicked on a different color. There we go. What if I asked you to find both of these angles? Now, I made them both single arcs, and they're a different color, so it's different than this. So what's true about these two blue angles right there? Well, the 2 angles don't add up to 180. The 3 angles do, but beyond that, more general. more general, what's the relationship between this angle and this angle? They're equal to each other. Why? Because this radius is equal to this radius, right? And remember we said in a triangle, if you got two equal sides, what's true about the angles? The opposite angles are equal to each other as well. So this is an isosceles triangle, isn't it? Okay? Everybody good with that? And where would the apothem be? I'll do it in a different color since I've already used red. Where would the apothem be? From the center, perpendicular to the side, or we could call it the base of that triangle, couldn't we? Everybody see that? So look, if I know this, I tell you what, let's find the blue ones. I should have done that first. Let's find the two blue ones. All right, so let's find this angle. If I find one, the other one's going to be exactly the same. All right, so again, let's look at that whole entire triangle. What did we say earlier? We said 180 what? Let's go minus 45 first. Why did I do that? Because I just want to find what these two angles add up to be. So if I go 180 minus 45, that's going to tell me these two. And that gives me 135. Does that mean this one angle is 135 and this one's 135? No. What do? Right, if you divide or together, they add up to 135. Now they're both exactly the same. So what could I do? That's right, I take that 135 divided by 2, and that gives me 67.5 degrees. Look at all that stuff that I could figure out without even knowing any numbers to begin with, except for the fact that you had 8 sides and they were all equal to each other. Okay, so I did know that, but I didn't know anything about any other angles. And check this out. I could find this angle right there, 67.5, and I could find this angle right there, 67.5. That's kind of cool, isn't it? Right, without knowing anything else. All I had to do was to go 360 divided by 8, which is 45. Take that away from 180. That's what these two add up to be. Since they're both exactly the same, right? I divide them both by 2, and boom, 67.5. I can do that with any number of polygon or sides of a polygon. Okay, I could do that with a 6-sided. I could do that with a 5-sided, a 10-sided, a 1,000-sided. All right. Do you agree? Yeah. All right. We are just about ready to find the area. So let's just do another polygon. Let's talk about one more thing. All right. All right, hurry back because we're getting to the good stuff. Yeah, I'll just stick with my notes. I could use any polygon. It really does not make any difference. But in my notes, I have another pentagon. So let's just use a pentagon. All right. Oops. What's that? Doesn't look like a pentagon? All right. There's the center right there. And what I'm going to do, I'm not going to draw everything. I'm not going to draw all the radii. Just going to draw this bit right there. And we're going to call this S. What do you think that S stands for? The side. Okay, that's the length of the side. So what's this side going to be right here? It's going to be the same. It's going to be S. And this would be S and S and S. But I don't really care about all of those right now, okay? I just care about one of them right now. There's another thing that I care about, and that's the what? The apothem. Everybody with me on that? So that's something that I care about. And another thing I could potentially care about is this one from here to here, and that would be the radius. All right, so that's pretty important. I'm just going to give you the area. I'm not going to, let's see. Yeah, we got a few minutes. So do you see this triangle that I just drew right here? I could also go to here, and go to here. what would be true about this triangle, this one, and this one? They'll all be the same, right? They'll all be congruent triangles. Agreed? So if I can find the area of just this one triangle, then how could I find the area of the whole entire thing? Okay, good. All right, times the sides, because there's 5 sides, there's 5 triangles, right? So you find the area of this triangle, and then this one, this one, this one, this one, they're all going to be the same, so you just add them all up. Or, since they're the same, you multiply them by 5, and you got the area of the whole entire thing. That's what we're eventually trying to do, is find the area of that whole entire polygon, okay? So the key is to find the area of this triangle, all right? Let's see what I want to do. So what is the area of a triangle? Base times height. Remember that? What?
Base times height
divided by 2. Good. Okay, so watch. I'm going to put 1/2. Is that all right? 1/2 the base times the height. So that would be the area of just this triangle right here. Well, what is the base of this thing? It's S. All right, so I'm going to put 1/2 times S. What's the height of this triangle? It's A for the apothem. Agreed? But that's just one triangle. How do I find the area of all the triangles? I multiply that by how many triangles I have. In this case, how many do I have? I got 5. Okay? Now, let me show you this very carefully. If I took this, let's do it in a different color. If I took this times 5, 5 times S, what am I really finding right here? This is the what? If I take this side times 5, what am I finding? From here, 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 here. Finding the distance around that whole thing, aren't I? What is the distance around something? It's the, starts with a P, say it. It's the perimeter. That's right. So that's basically the perimeter, isn't it? Where am I going with this? Well, here's another way I could write the area. Instead of base times height, or 1/2 the base times the height, and then make the height A and make the base S, and then figure out how many of these I have, this is what we do. We take 1/2 of the apothem times the what? Times the perimeter. So it's 1/2 the apothem times the perimeter. And there, we just kind of came up with our own formula, didn't we? All right? Yeah, I think that's kind of cool that we kind of came up with it. And you see why this works. All right? So this isn't just some formula that we just pulled out of the blue and we're like, somebody just thought of it off the top of their head. No, they did some research, and we did it too, didn't we? So we actually came up with that formula, which is kind of cool. That's why I did all that stuff right there. Now, we're finally ready to find the area of a regular polygon. I bet you just can't wait, can you? I could tell. Like, come on, Mr. Hammer, let's find the area. I'm sure you're thinking that. Well, I was. All right, so let's write it down. 1/2 the apothem times the perimeter. That's how you find the area of that whole entire polygon. So now, let's do an example. So I'm going to give you a regular octagon, and I want you to find the area of it. And they're going to give you some information, don't worry. And we'll write that down in a second. Now for me, it's easy to draw a regular octagon with my little computer program here, okay? I just pick an 8-sided thing and I just grab it and I got it. Drawing it by hand is kind of hard, isn't it? To make a really nice looking regular octagon. So what I'm going to do is this. I'm going to draw it where I don't have to draw the whole entire regular octagon. I'm just going to draw the portion of it that I think is important, all right? So the center of the octagon is very important, and the sides are very important, okay? Okay, so that's one of my sides right there. Everybody see that? That looks pretty good. And I got another side, I guess. You could put it in there too. That could be helpful. So look, I don't have to draw the whole entire regular octagon. Does this make sense? I just draw the part of the octagon that I think is important, all right? So what else is important to this? Well, look at my formula. 1/2 the what? The apothem. So I'm going to draw the apothem. How do I draw the apothem? From the center, how? Perpendicular to one of the sides. Correct? So that's important, so I'm going to draw that. What else could possibly else be important? Okay, I got a vertex already, but if I draw a line segment from the center to the vertex, that's the radius. So that could be pretty important as well. Even though it's not in my formula, on this problem, you really didn't need to know it. On the next problem, you definitely needed to see the radius, okay? So I did that. So that's all really you needed to draw. You didn't really have to have anything else. That's a lot better than drawing that whole entire octagon. Would you agree? Yeah. So that's all I had to draw. It's just a zoomed up version, right? Okay. So here's what they tell you. They tell you this. They tell you that one of the sides is 10 centimeters. And they also tell you the apothem. The apothem is 12.1 centimeters. Again, the apothem is the red one. And what you need to do is find the area. This is about the easiest version of this problem they're going to give you. I'll let you know right now. Okay, the next one's a little bit more difficult, okay? But this one's about the easiest one that you're going to do. So if I want to find the area, I got to have an equation, a formula, don't I? There it is right there. So what do I write? 1/2 times the apothem. In this case, they tell me the apothem. That was nice of them. What is it? 12.1. Now, times the perimeter. How do I find the perimeter? Let's do it off to the side. Well, we could do it right here. I'll put the perimeter in right there. Is the perimeter 10?
No.
10 times 8. That's right, because it's an octagon. That means there's 8 sides, correct? So the perimeter is what? 10 times 8. That's the perimeter. Make sense? This is the apothem, and there's your 1/2. And it's as easy as that. Put it into a calculator, and you get what you get. What do I get? 484. 484. 10 times 8 is 80. Half of 80 is 40. 40 times 12 is 480, right? And then half of 8 is 4. Or you can put it into a calculator. But you see how it works. This is in centimeters, so my answer is what? Centimeters squared. And there you go. That's the first time you did the area of a regular polygon. Not that hard. You know why it's not hard? Because they gave you what? The apothem, okay? That's when it's pretty easy. Everybody with me on that? Okay, let's do another one. And this will be our last one. That was example 2. I didn't write that down. But this is example 2. Okay? Now we're going to do example 3, and we will be finished. We got 10 minutes. That should be plenty of time to do this. So this is example 3. This one takes a little bit of thought. But there's really nothing new about this. What was the last thing that we learned in here? The lesson. You remember? Special right triangles. What was the second special right triangle that we dealt with? 30, 60, 90. Very good. Okay? So the stuff that we're going to do right now, it's not new at all. We're just taking something from here, from here, from here that we learned before, and we're just putting it all together into one big problem. Okay? So it's really not new. You tell me if there's anything in here that we've never done before. All right? You can't, because everything we have done before. Okay? I'll tell you that much. All right, so here we go. We are going to find the area again. Find the area of a regular, this time it's a hexagon. Now there's a reason they made it a hexagon. We'll talk about it when we finish this, okay? But there's a reason why they made it a hexagon, and because they will not ask you, I don't think, well, we did an octagon earlier, but they told you the apothem, right? For this particular problem on what they give you, there's a reason why they made it a hexagon, and we're going to see it. So how am I going to draw this thing? First of all, I want to put my center That's the first thing you should do, okay? Draw a little dot for your center. Then I'm going to draw one of the sides. I mean, you could make it angled if you wanted to. I'm just going to put it right there. Okay? And then I'm going to draw another. This is a hexagon, so it's not quite as wide as a octagon. So we'll make it come about like that. That looks pretty close. Okay? Both of those lengths should be the same. What do we say is really important in our formula? The apothem. So let's draw the apothem. It goes from here perpendicular. It also does something else that we didn't talk about today. How do you think it hits that opposite side? It hits at a right angle, that's true, but where, that point right there, it's the middle. It's the midpoint, okay? There's reasons for it that we learned before. I'm not going to get into it. Just know that it does hit at the midpoint. Doesn't matter if it's a hexagon, octagon, anything, okay? It hits at the midpoint. Make sense? All right, so what if I knew that whole side right there? What would this little bit be? It'd be half of it, right? Okay? And then what's another thing I want to draw here, do you think? The radius, all right? So let's go from the center to this vertex right there. I haven't even given you anything yet, but you could draw this out. That's a regular hexagon. We good? And I tell you what, let's do this. I'm going to put another one right there. Why am I going to do that? I'll show you. The very first example that we did today, we found the central angle. Do you remember that? How did we find that central angle? Look in your notes if you need to. How did we find the central angle? We took 360, no, not times, divided by n. How many sides you have? Well, this is a hexagon. How many sides does a hexagon have? 5? 6. Pentagon is 5. Hexagon is 6. So you got to know that, all right? So 6 sides. So I'm going to go 360 divided by what? 6. What is 360 divided by 6? 60 degrees. What is 60 degrees? That blue angle right there, that's 60 degrees. You with me? So that's good. All right, I'll put a little arrow. 60 degrees. What I really need, though, is I want to look at this triangle. By the way, they do give you a couple other things. Well, they give you one other thing. They tell you that that is 4 inches. So if they tell you the sides of the hexagon are all 4 inches, that means that the side right here is also what? 4 inches. But let's take a look at the triangle. Look at the right triangle. Remember I said we're going to use that? This is where we're going to use that right triangle. So what can I find out super easy? There's a couple things I could find super easy on this right triangle. Everybody see this one right here where I'm sketching over it? Okay, I'll tell you what. Let's sketch over it in a different color just so it pops a little bit more. All right? We'll just do it by hand. So see this one, and this one. Okay, that's what I'm looking at right now. What is this side? It's going to be a 2. That's right. Everybody see that? Because we just said it hits it at the midpoint. So if that whole side is 4, what's that little bit right there of that right triangle? That's 2. What is this angle right there? That skinny little angle. It's going to be 30. That's right. Because this bisects that whole angle. The whole angle is 60. So that angle right there is 30. So if this is 90 and that's 30, what's this angle right here going to be? This is going to be 60. So what kind of a triangle do we have? 30, 60, 90 triangle. Okay, that's why I asked you what was the last thing that we learned in here. It was a 30, 60, 90. So now we're going to use that information that we learned in the last lesson to be able to figure something out. By the way, what do we want to figure out? Well, what's the area equal to? It's 1/2 the what? The apothem times the perimeter. The perimeter is super easy. How could I find the perimeter of this thing? Yeah, 4 times 6, right? Which is 24. All right, so I know the perimeter is 24. That was no big deal. Everybody can do that. The key was to find the what? The apothem. And this one right here, it was red. Okay, I sketched over it in yellow, but the red one, That's the apothem. Now, check this out. I got a 30, 60, 90 triangle. I know the short side. How do I know 2 is the short side? Because it's opposite the 30 degree. What about this side, the apothem? What side is that? Is it the hypotenuse? Is it the short? What is it? This one right there is the what? Okay, but what do we call it? We had short, we had hypotenuse. What was the other one called? The long side. That's right. So the apothem is the what? Is the long side. So let's do some math. All right? We got to know our formula. What was the little formula for a 30, 60, 90 triangle? The long side was equal to square root of 3 times the short side. Okay? So really, once we find the long side or the apothem, we're pretty much done. It's pretty easy after that. Really easy. It's only one step and you're done. So we got to find the apothem though. That's the key. So what's the long side? The long side is equal to the square root of 3 times the short side. What's the short side? It's 2. How do I rewrite that? I don't want to write square root of 3 and then a 2. 2 square root of 3. So that's my apothem, isn't it? Now, to find the area is actually simple. You just throw it into the formula. So let's do that. Area equals 1/2. The apothem, what's the apothem? 2 square root of 3 times the what? The perimeter, what do we find the perimeter to be? 24. And now we just work this thing out. Watch how easy it is. I don't need to put it into a calculator. Everybody look. What's 1/2 of 2? It's 1. So that's a 1. And what's my answer now? Yeah, I'm going to write 24 first, right? And then I'm going to write square root of 3, and that's my area. And you can keep it just like that. This was in inches, so what's my area going to be in? Inches what? Squared. That's it. That's how you would write the answer. I know you guys don't like having a square root of 3 in the answer, but that's the best way to write it right now. If you really, really wanted to, you could always put it into a calculator and get an approximation. And that would have been about 41.6. That's also inches squared. I would accept either, but why take the extra time? Why take the chance that you're going to punch something in wrong in your calculator to get that 41.6? It's not that important at this moment. Okay, later on it will be, but right now it's not. Just keep it 24 square root of 3 is the easiest way to do that. All right, I don't have time to run over that again, but you do have it recorded. Watch it on the video. You should be good. So here is your homework. Splitting it up into 2 days. So here's your first day. So it's section 7.5a. And you are doing just 5 to 12. It's not that much. There you go. So 7.5a, 5 to 12. Have that finished for tomorrow. Then we're going to do part B tomorrow in class. Okay, after I go over these things. Everybody good? Nah, we might. I don't know. I'll make that decision tomorrow if we turn them in the same day or not. But have it ready, though. Have this done by tomorrow because I want to go over it. And you need to have had the experience of actually trying these problems, okay? All right. Have a good rest of the day.